welcome to this session. Today we will see how to construct and test a 1 to 4 demultiplexer. Understanding this important part will help you learn how digital circuits work, making it easier to manage signals in complicated systems.
Objectives. At the end of this session, you will be able to identify the tools and materials required to construct and test 1 to 4 demultiplexer circuit. Construct and test 1 to 4 demultiplexer circuit using IC74LS139. Let's now look at what a demultiplexer is. A demultiplexer or DEMUX is a digital logic circuit that routes a single input data stream to one of the several outputs, enabling efficient signal distribution. Selector lines control the demultiplexer, guiding the input to a chosen output based on a binary code. Only one output is active at a time. Essentially, a demultiplexer acts as a data distributor, encoding the path to dispatch a transmission to its intended destination. The 1 to 4 demultiplexer is a specific format where a single input can route to one of the 4 possible outputs. It follows the general DEMUX structure of 1 into 2 power 2. In the block diagram, one input line splits into 4 outputs. The input, often labeled as in or I, sends signals to 4 destinations y0, y1, y2, and y3. The single input is where the signal begins, and the 4 outputs are its destinations. Crucially, select lines S1 and S0 determine which of the 4 outputs will carry the input signal. As we examine the table further, the activated output varies according to the values of the select lines. If S1 is 0 and S0 is 1, output Y1 is activated, and this pattern continues for all combinations of the select lines. Let's now look at the tools and materials to construct and test 1 to 4 demultiplexer circuit using IC74LS139. You will require the following tools and equipment such as digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, tweezer 1 number. We will need the following materials and components: IC74LS139 1 number, hookup wires as required. Let's now see the IC74LS139, specifically designed for a dual 1 to 4 demultiplexer. The IC74LS139 has 16 pins. Let's now see the pin configuration of IC74LS139. Pin 1 and pin 15, labeled as G1 and G2, serve as enable inputs for the demultiplexers, which means it acts as a data input for the demultiplexer operation, and it is normally active low. Pin 2, A1, is the first selection input for the first demultiplexer. Pin 3, B1, is the second selection input for the first demultiplexer. Pins 4 to 7 are the outputs 1Y0 to 1Y3 of the first demultiplexer. These are active low outputs. Pin 8, G and D, is connected to the circuit's ground. Pins 9 to 12, that is 2Y3 to 2Y0, serve as outputs of the second demultiplexer. These are active low outputs. Pin 14, that is A2, and 13, that is B2, are selection inputs for the second demultiplexer. Pin 16, VCC, is connected to the plus 5V DC supply. Let's now look at the procedure of the construction and testing of 1 to 4 demultiplexer using IC74LS139. First and foremost, gather all the components needed for the construction of the 1 to 4 demultiplexer. Since we are using digital trainer kit, the major portions of the circuit like breadboard, power supply, switches, resistors, and LED are incorporated on that. Safety tip: be cautious while handling the IC, ensuring its delicate pins are not bent when placing it onto the breadboard. The next step is to mount the IC. Carefully place the 16-pin 74LS139 IC onto the breadboard. Ensure the pins are not bent while mounting. Connect VCC to the positive terminal of the breadboard. Connect the ground to the negative terminal of the breadboard. Use a jumper wire to connect pin 16 to the plus 5-volt power supply. Connect pin 8 to the ground on the breadboard. The next step is to set up the input. Connect enable pin 1 to the ground of the breadboard. Next, we have to attach the additional setting switches. Connect the selecting input pin 3 to the switch 5. Connect the selecting input pin 2 to the switch 6. Connect pin 4 to the LED Y0. Connect pin 5 to the LED Y1. Connect pin 6 to the LED Y2. Connect pin 7 to the LED Y3. The next step is to further check all the connections. Double check that each wire is properly inserted and there are no loose connections. Briefly test the toggle switches to ensure they flip between the states smoothly without causing any loose connections. The next step is to test the circuit. We will set the DC power supply to the plus 5 volt. Activate the power supply that is connected to the breadboard. This supplies the necessary voltage to the 74LS139 IC and other components. Now, we will verify power distribution. Ensure that plus 5 volt is reaching the IC correctly by checking the voltage at pin 16 and ground at pin 8. We will now do the initial setting for testing. When the input signal is low, selecting switch activate. One LED is off, while the remaining LEDs are on in this state, indicating a change in the outputs. This indicates that the demultiplexer is operating correctly by providing a low output when there is a low input signal as specified by the selecting switch. To further test the circuit, we will adjust S5 and S6 switches. We will test different combinations. Each combination of S5 and S6 settings corresponds to one of the 4 outputs of the demultiplexer being activated. Toggle the switches S5 to low and S6 to low, then the output Y0 LED will be turned off and the rest all LEDs will be turned on. Toggle the switches S5 to low and S6 to high, then the output Y1 LED will be turned off and the rest all LEDs will be turned on. Toggle the switches S5 to high and S6 to low, then the output Y2 LED will be turned off and the rest all LEDs will be turned on. Toggle the switches S5 to high and S6 to high, then the output Y3 LED will be turned off and the rest all LEDs will be turned on.
This brings us to the end of the session. In this session, we have learned to identify the tools and materials needed to construct and test 1 to 4 demultiplexer circuit and construct and test 1 to 4 demultiplexer circuit using IC 74LS139. Thank you for watching. We will see you in the next session.